who is a summer intern working with Jon, and he's a rising senior at Dartmouth College studying computer science and mathematics. So welcome.
Hi. Should I start?
Yes, please.
All right. Well, hi, everyone. My name is Ugur, and I was an intern working with the Natural Language Group this summer under the supervision of Dr. Jon May. And today I am going to describe the outline of and my work on the project I had the opportunity of working on throughout the summer. And before starting, I would like to note that this was my first experience working with machine translation or natural language processing technologies in general, and also doing research on the topic. And this was an experience I thoroughly enjoyed. And I hope it will maybe act as somewhat of a potential catalyst to perhaps what is a career in this field. All right. To get things started, I first would like to explain what the project is all about. And I first want to begin with an observation that motivated Dr. May to start this project in the first place. Many immigrants seeking asylum along the southern border of the United States do not speak Spanish or English. As a matter of fact, a considerable number of them speak low-resource languages that are not widely available on commercial translation services. And this situation causes significant challenges for the legal system, but also non-governmental organizations providing advice and legal support to asylees, as the interpretation of their testimonials in courts require extensive and expensive professional translation services, which are not financially viable. And without such professional preparation, the chances of success of these asylum cases unfortunately drop drastically. With this observation, the problem is clear, and the question arises, how can we go about translating asylum testimonies given in low-resource languages into English in a more viable and sustainable fashion? And today we are going to discuss how we can leverage machine translation techniques as a potential solution to this problem. For the purpose of this project, we have chosen to focus on 4 low-resource languages specifically: Mixtec, Kanjobal, Mam, and Luganda. And although I should note that my work has been mostly focused on Mixtec and Kanjobal this summer. And regarding the 4 languages, you may notice that it is somewhat of an unusual juxtaposition, as the former 3 are Mesoamerican languages, which I suppose may be expected given the geographical proximity of the region to the United States. But the latter, Luganda, is a Bantu language, but nonetheless, it turns out Luganda is among the most commonly spoken languages among asylum seekers hailing from sub-Saharan Africa, and hence why we decided to include this language as part of our study. Of course, attempting to create translation models for these languages is impossible without some initial input. And in this case, a sizable amount of translated sentences from the given language into the target language, which in this case is English. And consequently, a significant challenge for the translation of low-resource languages is the gathering of this data in the first place, and as these languages often have very low online presences. And even when they do, it is not easily possible to find bodies of text readily available in the respective language and English. Hence, I spent a considerable part of my internship creating bilingual corpora for Mixtec and Kanjobal. Fortunately, for the case of Mixtec, I have had quite some luck, as just last year, 4 researchers from the National Autonomous University of Mexico, led by Cynthia Montaño, have published a paper about a Mixtec Spanish corpus they compiled. The corpus is important in that, in most such cases, translations of the Bible is the exclusive source for the body of text in question. And although here, Bible is still the most prominent source of text in the corpus, they also have translations of various documents like town descriptions, traditional stories, and even some food recipes. And this certainly adds a much needed variety to the corpus. After some communication with the researchers, I gained access to this corpus. However, this corpus was somewhat difficult to navigate. You see, despite being, in fact, publicly available, this was not immediately usable due to the fact that it was only available through their own web interface, and the queries were running extremely slowly despite the relatively small size of the corpus. And besides, queries were very limited in structure and would only return a list of sentences. So querying for documents was out of question, and the limited structure of the queries made it impossible to ask for the entire corpus through a single query. Furthermore, even if they gave you the option to download the queried sentences, the metadata was not available in a similar downloadable format. Nonetheless, upon discovering that the format of the output to each query maintained the order of the documents in the corpus and the respective sentences within each document, I was eventually able to recreate all the documents in the corpus by using a number of queries and joining the results carefully. I was also able to scrape the metadata information they provided on their interface. Upon a closer look at the corpus, I did some additional cleaning. For instance, in Mixtec translations, I noticed that sometimes numbers of Bible verses or legislations were mistakenly concatenated to the first word of the sentence. And I also saw occasional inconsistencies in the notation of glottal stops. And these errors are things that may cause quite a lot of confusion in the process of training translation models. Luckily, these were easily manageable errors through the use of regular expressions. In fact, you can see one such error here. This is the first verse of 2 Peter 1. And in the Mixtec version, the verse number seems to be concatenated to the first word, whereas it is separate in Spanish. And of course, this was a Mixtec Spanish corpus, but luckily we have many high quality Spanish English translation services immediately available. And I used Google Translate's API to convert this Mixtec Spanish bilingual corpus into a Mixtec Spanish English multilingual corpus. And after this processing, the final version of the corpus I compiled contains around 18,000 distinct tokens and 12,000 sentences and is available on GitHub. Next, I was not able to find a similar study on any of the other languages, but I was able to use two different literary resources to compile a Kanjobal corpus that was somewhat similar in size. One of them was, of course, the Bible, and specifically, I stumbled upon a Kanjobal translation of the New Testament on Bible.is, which is run by a nonprofit organization that provides the Bible in many languages of the world. I scraped this translation to somewhat kickstart my Kanjobal corpus. The fact that verse numbers are specified and are consistent across different languages, different versions of the biblical canon, is very helpful when compiling bilingual corpora, as it makes it much easier to align parts of the text. But rather unexpectedly, there were some verse number mismatches between the Kanjobal New Testament and the English edition I was using, which I had to take into account when working on the alignment. Specifically, a few dozen chapters had more verses in English than in Kanjobal, and very few, I believe there were two, were such that Kanjobal had more verses. In the former case, they were all due to a number of English verses being concatenated into a single one in Kanjobal, and following the numbering of the verses was relatively straightforward to handle this error automatically. You can see an example of this here above, where looking at the proper names, it is quite easy to conclude that verse 9 through 13 in English have been concatenated into just verse 9 in Kanjobal, and the verse number in Kanjobal jumps to 14 right after. The other case, where there were more Kanjobal verses than English, however, is a bit more different in that it was due to an English verse being split into multiple verses in Kanjobal, and the contradictory numbering followed suit. As you can see below, the last part of verse 15 in English has been made a separate verse in Kanjobal, verse 16, but the numbering in English doesn't abruptly jump to 17 as it would in the previous case, but it goes on normally. It ends at 16 and Kanjobal ends at 17 verses instead. And this makes it a little more difficult to handle than previous case, but as I mentioned, there are only two such cases, so this was quite easy to handle simply manually. I was also fortunate enough to get access to the scan of a rare trilingual Kanjobal Spanish-English storybook that contained stories in all three languages, which were aligned on a paragraph basis. I was able to scan the contents of this book with the open source OCR engine Tesseract by using a mixture of its pre-trained English and Spanish readers to scan the Kanjobal bits, and this worked remarkably well. As you can see, this passage, which is the first paragraph of the book, resulted in only one misinterpreted letter and a minor punctuation error. You can see that the Q in the fourth word of the paragraph has been misinterpreted as a G, but other than that, there is no letter misrecognitions, and the punctuation error is very negligible. It's just an error in the scanning of an apostrophe of a glottal stop. I then worked on fixing such OCR typos and manually broke down paragraphs into sentence-like segments, because the finer the alignment is, the better results we can get in terms of translation. And with this addition, after all this processing, the final version of this corpus I compiled contains around 8,000 sentences and around 12,000 distinct tokens. In terms of future work regarding the resource gathering aspect of this project, I suppose the immediate next step would be to look for parallel bodies of text for the languages I haven't been able to focus on, namely Mam and Luganda. And one other thing I should note is that the size in terms of number of sentences and tokens in each of the corpora I have been able to gather is magnitudes away from what would be considered enough to train translation models on their own. And this observation, I suppose, serves as a good segue for the discussion of the other part of the project, that of building and improving the translation model. I have to admit, working with such small corpora, and perhaps due to my inexperience in NT until recently, I have not been able to make as much of a breakthrough as I would have liked to in terms of training a satisfactory translation model, at least during my time in this internship. The baseline translation models I have been able to build using the Mixtec corpus never exceeded a blue score of 2, and I got even worse results with Kanjobal. Hence, in this part of the discussion, I will mostly discuss certain ideas that may help improve baseline models rather than concrete results. Perhaps the most obvious technique to improve translation models that suffer from a lack of data is to make use of models that are already used for similar purposes that have been trained on larger amounts of data. In other words, use these pre-trained models as a basis model, which is further trained in the task we try to achieve. And this obviously follows from the definition of fine-tuning. In the context of machine translation, this model may very well be models that have been trained on other languages. This approach was actually studied by Dr. May and one of his PhD students, Mujde, in a paper last year. And part of what was done within that paper was to train a translation model on 2 million sentences from the massive Giga French English corpus, which acted as a parent model. Then they fine-tuned the parent model using the corpus of the actual source language to create a child model, which exhibited an improvement in accuracy over the baseline model. They also introduced the concept of a universal parent model trained on a universal corpus of 2 million sentences in total from 19 different languages, all of them translated into English. This provided an even further improvement over the baseline, as can be seen in the graph. But here, of specific interest to this project is their experiment with Estonian on the rightmost column of the graph, because both the size of the corpus used and the accuracy of the baseline model seem quite similar to my experience with Mixtec. I had been tinkering with this technique during the last weeks of my internship, aiming to sort of recreate this experience using the same setup. I was using the tensor-to-tensor implementation of the transformer. Although I haven't been able to succeed in the small time window, I believe that working with this transfer learning technique would be the most straightforward next step for this project, and also pave the way for the application of the idea that I would like to discuss next, which is that of domain adaptation. So far, we have been talking about the translation task in general, but we haven't put the domain of this translation into consideration yet. And as one could imagine, asylum testimonials are, generally speaking, reflective of difficult life experiences and the notion of displacement. Yet the types of corpora we have access to and have been talking about so far do not provide bodies of text that belong to this type of domain in general, causing somewhat of a domain mismatch. Therefore, we should at the same time aim to tune our models to specifically handle this type of context, the context of the difficult life experiences of an asylum seeker. To this end, we hope to leverage Moloch, which was developed in part by the USC Shoah Foundation Institute. And this is a large collection of digitized English interviews with thousands of survivors and witnesses of the Nazi Holocaust. And we currently have access to the transcripts of these interviews. Given their context, we hope to be able to leverage the contents of these transcripts containing accounts of difficult life experiences, which are of a similar nature to those that can be found in immigrant narratives. And we hope to leverage this with a technique called back translation. And this technique consists of training a preliminary translation model with whatever bilingual data is available, then taking the monolingual target in-domain data, which in this case is the Moloch corpus, and have it be translated into the source language. Now that we have a tentatively translated domain-specific corpus, we simply use it to augment our training corpus with the hope that it will improve the model's performance and the translation of texts belonging to this special domain. And although I haven't been able to incorporate this corpus into learning experiments by the end of my internship, with the goal of getting the corpus in a format suitable for use for this goal in the future in mind, I have spent time cleaning the corpus and preparing it for use for domain adaptation purposes. You see, the transcriptions we possessed contain tags from the transcription software, and Additionally, we were specifically interested in what was spoken by the interviewees in terms of the domain and not the interviewers, because they ask questions and clarifications, but they do not recount the type of events that we are interested in. We also cleaned the contents of the interviewees' answers a little bit. For instance, stuttery answers were transcribed with parts of a given word being repeated multiple times, so we got rid of those as well. This part of the cleaning was easy to achieve through the use of regular expressions, but I should also note that these transcriptions did not include any punctuation and were divided by somewhat arbitrary timestamps instead of actual sentences. And it is much more preferable to have complete sentences as our units in the corpus when we are trying to learn the translation model. Fortunately, I have been able to leverage a Python library developed early last year named Deep Segment, and this library specializes in the segmentation of texts without punctuation into sentences to quite satisfactory results. So here is an example. On the leftmost side, I have a few lines from the Moloch transcription itself without any modifications. And you can see the tags from the transcription software. You can see in the first spoken line, the stuttering of the letter D, as which was supposed to be part of the word child, but it got kind of messy. And after the initial cleaning through regular expressions I mentioned, I was able to get the part in the middle. And here we see that lines 1 and 2 actually belong to the same sentence. The subject of the sentence is on one line and the action is on the other. So we obviously want to have them both on the same line. And Deep Segment is able to achieve this quite easily. And we get a quite clean format, especially considering what we started with at the end of this cleaning process. After all this processing, the cleaned Moloch corpus contains around 74,000 sentences and sentence-like fragments, and around 23,000 unique tokens ready for use for domain adaptation purposes in the future of this project. One final potentially helpful technique that I haven't spent as much time working on is that of corpus augmentation. Well, corpus augmentation is artificially enlarging the given corpus by applying some reasonable transformations. As a matter of fact, the domain adaptation technique could also be considered a method of corpus augmentation, but I wanted to talk about corpus augmentation techniques in general in this section, not necessarily domain-specific ones, especially in comparison to tasks such as image processing, where data augmentation techniques such as flipping the image, a very simple one, can be very helpful. Finding corpus augmentation techniques for NLP tasks like machine translation is not trivial due to the fragility of semantics. Even the simplest modification can make a perfectly meaningful sentence practically incomprehensible. One approach suggested by Fadai and others in 2017 is surprisingly reminiscent of the popular game Mad Libs. And in their augmentation, they specifically target low frequency words by generating new source and target sentence pairs containing rare words in the corpus in a new syntactic context. They break this process into 4 straightforward steps. The first one being picking targeted words, where each targeted word occurs fewer than a provided constant number of times in the corpus. The second part being rare word substitution, where given a sentence pair and a position in the source sentence, they generate a list of rare words that are among the most likely to appear in that position, given the preceding and the following word in the source sentence. And then they generate augmented source sentences using each by simply replacing the word whose position was given in the first place. Then the next step is translation selection, where among the potential translations of the rare word, the one which maximizes the probability of the candidate word being the translation of the augmented word and vice versa, and additionally the probability of the candidate word being where it is in the sentence according to the target language corpus. But there's also the caveat that there's a lower threshold of probability at this step, and if this probability is not exceeded, the translation is simply discarded in order to reduce the risk of generating practically incorrect sentences. Finally, sampling is done by simply going over the corpus many times, making sure to augment each rare word a number of times until no new sentences are generated. One downside of this technique is that the learning of these probabilities, at least in the experiments conducted by the authors of the paper, use corpora that are much bigger than our low resource corpora. Noting this, another interesting approach to this task was proposed by the authors of a 2018 paper in the form of an algorithm named switchout, which was designed by formulating the augmentation task as an optimization task. Without going into much detail, the authors use a probabilistic framework where they define probabilistic distributions over pairs of source and target sentences, then define two concepts. First, that of diversity, which is in correlation with the size of the support set of the set data distribution, and smoothness, which is a measure of similar sentence pairs having similar probabilities in the data distribution. The authors then use these concepts to define an objective function, and the switch-out algorithm, given an initial sentence pair, generates a new pair while maximizing the objective function over the corpus. It is important to note that the authors of switch-out report a 2-3-point increase in the BLUE score of a model that is already in the 20s to begin with, far from where our baseline model with Mixtec or Kanjobal would be as of now. Nonetheless, both of these algorithms have publicly available implementations, and I therefore believe that these are also valid improvement methods that could be easily examined in the future of this project. With that, I think I'm done talking about potential techniques to improve the baseline translation model, which I suppose brings me to the end of this presentation. And to sum up, the goal of our project is to build translation models for the translation of asylum testimonies of asylum seekers along the southern border of the US that specifically focus on 4 languages: Mixtec, Kanjobal, Mam, and Luganda, and all these languages are low resource languages. I personally spent a considerable amount of time compiling and cleaning 2 corpora, one for Mixtec and one for Kanjobal, and I also cleaned the Malak interweave archive to create a mostly sentence-fragmented, domain-focused monolingual corpus to be used for domain adaptation purposes in the future. I unfortunately have run out of time trying to establish a fine-tuning pipeline and experiment with different parent models to improve the performance, but I think this would be the most straightforward future step for this project. And I also believe attempting to make use of both domain-specific and domain-agnostic corpus augmentation techniques I mentioned could quite likely be an alternative approach to attain improved translation performance. Thank you for listening.
Thank you, Ugur. If anyone in the audience has any questions, you can just feel free to say it out loud, or you can leave a question in the chat, anything you want. So does anyone have any questions or comments?
I have a quick question, if I may. This is Ulf.
Hi.
So thank you very much. Good night, in. Enjoyed the talk. For the Bible, you mentioned that there were 2-3 places where the number of verses didn't match, and you had to do a little bit cleanup.
Mm-hmm.
Did you verify at all whether there might have been chapters where the number of verses might have been the same, but still there might have been alignment problems?
Oh, sorry, could you say it again?
Have you checked whether there might have been chapters in the bytext with the same number of verses, but that still don't quite match, right? So you might have, you know, one verse that is kind of long in another language and short in another, where the second part is kind of picked up in a different verse.
I see. I haven't specifically gone through those, but I believe there could be that type of exceptions as well. Although I thought the general assumption was that verse numberings are quite consistent and the translations also. So I only went through the process of individually checking them if I saw a mismatch in terms of numbers, not in terms of length. But I suppose that would definitely be a way to improve the corpus itself, looking into the verses in terms of number of sentences, length of sentences, right, and look at the potential mismatches there.
Mm-hmm. Okay, thank you.
Any other questions, comments? All right, I have 2 related ones. So sort of in general, what are some of the difficult issues you sort of face with collecting this limited corpora? And related, do you think anything can be automated, like any components of this collection process?
Finding resources in general was difficult. I mean, one can always find translations of the Bible, but other documents, they're very impossible. The Kanjobal book I was able to find, I was simply looking at different library websites, and I just happened to find it, but it was pages deep and not really available. And I had to ask for the scan, and then I had to wait for weeks. Then when it came, the OCR, etc. I suppose it could be automated to a certain extent, but we don't know if that many books exist in the first place to start with. I mean, this Kanjobal book, is this a one-off thing, or are there other books in depths of other libraries? So I suppose, yeah, it could be automated to a certain extent, but I'm not sure how many resources are available to start with.
I see. Thanks. Anyone else have comments or questions?
Well, I wanted to thank you, Oren, and note that you know, the data processing part of these kinds of research efforts that are getting into new data sets and new kind of areas that haven't really been covered before can, you know, I detect a sense of, you know, regret that you didn't get to the modeling parts. And I think I want to tell you that, at least from my perspective, you know, this is very necessary work and difficult work just to get to this point. And it's, you know, it takes a while to get there. You know, this is more dirty than other kinds of data sets, you know, that we still need to find even more data. Justin can tell you how long it took him to get to the point in his previous work where he was able to actually run some kind of experiment after having to do data gathering. Yeah, it's a, so thank you.
Yeah, I was about to comment the same in terms of that. I really appreciate how you started really from scratch and kind of understand how difficult that process is. I believe it's even more difficult for you based on what you've been describing. So a great job. And I think, yeah, you'll definitely be enjoying the modeling part more since you've come up with the entire data set. So yeah.
Thanks.
Yeah, the fish tastes better when you catch it yourself.
Cool. If there are no other questions or comments, then we'll wrap up the seminar. Thank you, Ugur, and thank you for the audience for participating.
Thanks, everyone.
All right. Bye-bye.